All right, we're going to continue with example number 3. Here we have another spinner, but this time it has 20 sections from 1 through 20. We want the probability of spinning a multiple of 2 or a multiple of 3. So we want P of multiple of 2 or multiple of 3. Again, we should be asking ourselves, is this mutually exclusive? Is there overlap? So good way of doing it is just to write it out. So multiples of 2 would be 2, 4, 6, 8, 10, 12. 14, 16, 18, and 20. And then the multiples of 3 are 3, 6, 9, 12, 15, and 18. So do we have any overlap? And we can see that we have the 6s in common, we have the 12s in common, and we have the 8s in common. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 that are even, multiples of 2. We have 1, 2, 3, 4, 5, 6. 6 that are multiples of 3. And our overlap, we have 3 that overlap. So we're going to kind of be using those numbers to help us out. In terms of the Venn diagram, we have the 6 here, the 12, and the 18 in the section. The rest of the numbers go on the sides. So let's go ahead and figure out our probability. So here we're going to have to subtract the repetition of 3 numbers. So we need the probability of multiples of 2 plus the probability of all the multiples of 3. But then we have to subtract the overlap, which is where multiples of 2 and multiples of 3 happen at the same time, which is that center section. So we already know multiples of 2 are 10 out of 20. Multiples of 3 are 6 out of 20. And the repetition or the overlap is 3 out of 20. We add and subtract these numerators, so we're going to get 13. Denominator stays the same. Final answer, we can't reduce it. Let's move on to number 4. That's what we just saw. Let's go ahead and do this one. All right, so we're going to go ahead and find the probability of picking a king or a spade in a deck of cards. So we're going to do a king or a spade, or if you prefer to write it in a cleaner way, you can just do P of K, and then just do that little backwards heart if you prefer, or you can just write the words out. All right, let's go ahead and look at a standard deck of cards, all 52 of them. So let's look at the kings and spades. So we have the kings right here. So let's see. So this is where we have all kings, and we have 4 of those. And then we're going to look at the spades, which are all of these down here. There's a total of 13. And then we're going to look at the overlap, which is in this section right here. So we overlap right here in this bottom corner. There's only 1 card that overlaps, so that's going to be my subtraction. So I'm going to double count this card, so I have to make sure I go back and subtract it. So we had 4, 13, and 1. Just quickly write those numbers out when I get to the next slide. It was 4, 13, and 1. I'll just write it right there on the side. So we want the probability of getting a king or a spade. So we're going to have to find the probability of K plus the probability of getting a spade, that backwards looking heart thingy. Then we're going to have to subtract the cards that are both kings and the spade. So the double count or the overlap, because these are non-mutually exclusive, they overlap. So kings, we said there are 4 out of 52 cards. Spades, we said there are 13. All the numbers, and then jack, king, and queen, which adds 3 more out of 52. And then there's 1 king of spades, which repeats, so we have to subtract it. And my total is going to be 16 out of 52. This one you can actually divide it by 4. So that gives me a final answer of 4 over 13. Let's move on to the next one. And there's the actual Venn diagram for this one, just in case you were wondering what it looks like. So there are all the cards for us, what we just saw right now. Let's see it over again. All right, let's go ahead and move on to the next one now. All right, so what is the probability of us grabbing an ace or a jack? So in this case, these are mutually exclusive because you're either going to have an ace card or a jack card. There's no card that has an ace and a jack on it. So these are mutually exclusive. So here we would just go ahead and say, how many aces are there? There are 4 out of 52. How many jacks are there? There are 4 out of 52 as well, which gives us a total of 8 out of 52, which means we're going to divide by 4 again. With cards, you'll usually end up dividing by 4. And we're going to get 2 out of, let's see, how many 4s go into 52? 13. All right, let's go ahead and move on to the next one and the last one. All right, there it is. What's the probability of us getting a diamond card and a face card? So is this mutually exclusive or not? Can both happen at once? Is there a diamond card that has a face on it, meaning Jack, King, and Queen? Your answer should be yes. Let's look at what that looks like visually. So there it is. So the face cards are all the Kings, Jacks, Queens. And 3 of those cards have a diamond on it. So that's a King of Diamonds, a Queen of Diamonds, and the Jack of Diamonds. Those are the 3 face cards that have a diamond on them. So there's going to be 3 on the repeat. So there's 3 cards here. Again, the total face cards, we have 3, 6, 9, 12. We have a total of 12, 3 which repeat. And the diamond cards is a total of 13 of them, 10 which don't overlap, and 3 which do overlap. So let's go ahead and find our probability. So it's going to be P of diamond plus P of a face card. I'm just going to put face on it. Minus a repeat, so I'm going to put P of it being diamond and at the same time being a face card. So both of them happening at once. So diamonds, we said we have 13 out of 52. Face cards, we have a total of 12 out of 52. And the ones that are both, the ones in common, are 3 of them, which we counted twice, so we have to subtract it once. Which gives us, that's 25 minus 3 is 22 out of 52. We're going to reduce this by dividing by 2, because it doesn't divide by 4 in this case. And we're going to get 11 out of 26 as our final answer. All right, so finishing it up. Just as a quick summary, it's very important to understand that when we have the words and the words or, and is just like I want this and then I want to grab that. So you're grabbing 2 separate things and you use a multiplication rule. The or is when we use addition rule where we're saying we want to grab this card or this card. So it's kind of one thing happening at once, but you're satisfied with either of the 2 things happening. You're not grabbing 2 separate things. And sometimes they will overlap or both will happen at once, which means we have to subtract the double count. So we have to subtract off that double count. So that's where we have to be very careful and ask if it's mutually exclusive. And now go ahead and start your exit ticket. So on the exit ticket, you will go over whether it's mutually exclusive or not for each problem on your actual classwork. You'll know if you got it wrong, and then you'll know if you have to either subtract that double count or not subtract the double count. All right, go ahead and get started.